Hello, this is the Boon channel. In the previous video, we set up a Kubernetes home lab accessible via the internet using K3s. In this video, I will show you how to develop applications in this environment. First, I'm going to talk about the container registry, how to build and push images to it. Here's a picture of our Kubernetes environment. On the right side, you have a K3s cluster and a home server, and you also have a private container registry running in it. Now you are here outside of your home network. You can access your services running in a cluster by setting up Cloudflare tunnel. However, setting up a tunnel for your container registry doesn't work because Cloudflare tunnel doesn't allow you to push a large image into your local network. If you want to publish an image, you need a public container registry. However, when you are developing an application, you can push images to your private container registry even if you are outside of your home network. In the previous video, we set up an SSH tunnel to our home network. We can use it to connect to the Docker daemon running on our home server. My .ssh config is here. I use this hostname. Replace this with your actual hostname. I set the environment variable Docker host like this, so the Docker CLI talks to the remote engine over SSH instead of my local daemon. Behind the scenes, the CLI opens an SSH session to boon.dev and tunnels the Docker Engine API through it. From the CLI's point of view, Docker build, Docker push, and Docker run all hit the remote engine. As a bonus, it saves laptop battery during Docker build. I tag images with the prefix localhost 30500. That address works on my home server, both inside and outside the cluster. Pushes happen from the remote host network point of view. If that host can reach the private registry, Docker push succeeds even when my laptop can't reach it directly. Let's try it with an example. Sample web app. It's a simple Next.js app with Drizzle ORM connecting to PostgreSQL. Clone it, export Docker host, and build the image. Then push it to the private registry. As mentioned earlier, the localhost 30500 tag is reachable inside and outside the cluster. Now, let's deploy the application. First, I'll create the database. If you're using Boonstack, go to the Boonstack directory and run just Postgres, create user and DB. I'll deploy the application with a Helm chart from the directory charts sample web app. Create a values.yaml like this. I install the chart and then check with kubectl. The deployment comes up successfully. Let's access the service next. I could do a quick kubectl port forward and open it in the browser, but redoing that after every deploy is a bit tedious and it doesn't integrate DNS. Instead, I'll use Telepresence. Once I'm connected, I don't need port forwarding at all. My laptop gets cluster DNS and routing, so I can use service names directly. Telepresence lets a local process join the cluster network and DNS, as if it were running in Kubernetes. With DNS integrated, you can hit any cluster services by name. For our example project, you can access the application with this URL in your browser. Now, let me show how I start Telepresence. First time only. I install the traffic manager with Telepresence Helm install. Then I run Telepresence Connect. On some platforms, you'll get an admin prompt the first time. From here on, my development machine resolves service names and routes traffic through Telepresence. Opening this URL just works because DNS is integrated with the cluster. With Telepresence connected, GUI tools work too. For example, here's DbGate, a database manager. I can connect using the service DNS name, like servicename.namespace. When I'm done for the day, Telepresence quit disconnects. Now that Telepresence takes care of networking and DNS, the next bottleneck is our inner dev loop. Build, tag, push, and roll out changes over and over again across multiple services. Doing Docker build, Docker push, and then Helm upgrade by hand is both slow and easy to get wrong. So here's what I'm looking for in a dev orchestrator. Let me walk through each one. Fast incremental rebuilds. It only rebuilds what changed, so results show up quickly. Instant live sync. Local edits sync into the container right away. Unified logs and forwards. Logs and port of forwards are in one place, so feedback is fast. Skaffold, Tilt, and DevSpace do exactly this. With them, changes show up in seconds. Skaffold is a declarative dev deploy tool. Here's a tiny scaffold.yaml. Tilt is a flexible dev orchestrator you program with a Python-like language called Starlark. Here's a minimal Tiltfile. DevSpace is a batteries-included remote dev tool. Here's a minimal devspace.yaml. Here is the GitHub star history of these tools. Each tool has its own unique features and strengths, making them suitable for different use cases and preferences, but I recommend Tilt for its flexibility and ease of use. Here's the Tiltfile for our sample web app. First, we define a few custom command line arguments, for example, a default container registry. Next, the image build. Since Tilt respects .dockerignore, live update is just one sync line. Finally, we deploy with Helm. Values can change by environment, driven by the args we defined above. Let's run tilt up and see it in action. The CLI prompts me to press space to open Tilt's web UI in my browser, which shows the status of my Kubernetes resources. I select Sample Web App, and the UI shows logs for Docker build, Docker push, and the Helm release. In this demo, Docker build completes instantly because I haven't changed any code since the last build. The app is deployed. Let's open it in the browser. It's up and reachable. I'll check live updates now. I'll change the title to To-Do App Test and save. The browser updates immediately, no manual steps. Next, I'll tweak the Docker file. Tilt detects the change and rebuilds just the invalidated layer. I'll fast forward the build and push here. When the push finishes, Tilt redeploys automatically. Finally, I'll update the Helm values. Tilt detects the change, re-renders the manifests, and reapplies them. When the rollout finishes, the new settings are live. That's the Tilt dev loop. Watch, live sync for code, rebuild on Dockerfile changes, and Helm redeploys all with clear feedback. Next, a few Kubernetes development tips. If you haven't set it up yet, here's how to enable kubectl autocompletion. It makes a big difference. If you're on Z shell, add the following to your .zshell rc. For example, tab complete pod names like this. To make the output easier to scan, use kubecolor and alias kubectl. Don't forget to map completion, so kubecolor reuses kubectl's completion. For convenience, I also add a short alias. If you're on Z shell, define a global alias to make kubectl output easier to read. Normally, you'd run this to print a manifest in YAML. With the alias, you can write it as this. Here are two more global aliases I use. W is shorthand for -o wide. It shows extra columns. YE is like Y, but it opens NeoVim instead of a pager. To watch resources in real time, dashboards like K- and K9s are great, but I generally stick to kubectl plus viddy. Viddy reruns a command and highlights changes in the output. You can also choose a past timestamp to view that run's output. I use this alias to pair viddy with kubectl. Many of you already use kubectx and kubens. They make switching contexts and namespaces easy. For logs, I recommend Stern. It tails logs from multiple pods at once, filter by name, regular expression, or label selectors. Here are a few quick examples. Today, we built a smooth inner dev loop for a Kubernetes development environment. Remote Docker over SSH to push to the private registry. Telepresence for DNS and routing without port of forwarding, and Tilt for watching, incremental rebuilds, and live sync with clear feedback. We wrapped with a few Kubernetes CLI tips to make day-to-day work easier. This setup should make Kubernetes development faster and less error-prone. Thanks for watching.